Hey class, it's Mr. H here, going to do some 4.2 binomial experiments. A binomial experiment is a type of probability experiment that satisfies some specific conditions, and they're listed here on page 3 of your chapter 4 notes. Basically, it's an experiment that's repeated for a fixed number of trials. So we've got that going for us. Each trial is independent of the others. And there's only two possible outcomes, hence the name binomial, right? There can be a success or a failure. The probability of a success is the same for each trial, and the random variable x is going to count the number of successes. So a problem that could be tackled with binomial experiments would be something like this. If you flip a coin 10 times, what's the probability that you get exactly 3 heads? Right? That's a binomial experiment because each coin flip is independent of the others, and each outcome has two possibilities, a head or not a head, right? Success or failure, and that sort of thing, okay? It doesn't have to be 50-50. In that case, it is the probability of a success is 50%, the probability of a failure is 50%. It doesn't have to be that way. We could do with like a roll of a die, right? What's the probability if you roll a die 10 times that you get a 3 exactly 5 times, right? So each one would be you either do get a 3 or you don't get a 3, right? The probability that you do get a 3 is less than that you don't get a 3, but it's still a success or a failure. Binomial experiment. Okay, we've got some variables here that you want to get used to, so I included this little thing for a reference. When they start talking about n's and p's and q's and x's, we'll refer back to this. And then you have your main formula here. For these problems, you can use that formula, or I'll show you a way that you can use the StatCrunch calculator. We'll do both. Okay, so here's our example. You have a multiple choice quiz in your history class. There are 5 questions. Each question has 4 choices, one of which is correct, and then there are 3 that are incorrect. Right, you did not study and you don't have any idea about the content. You plan on just randomly guessing. All right, so we're going to do some questions about that. But first, is this problem a binomial experiment? Right. And that should say verify that this problem satisfies the conditions of a binomial experiment. So let's change that right now. Is this binomial? And now look back at my conditions. Fixed number of trials, check. Independent, yeah, each question is going to be independent of the next, right? There's no relationship among the questions. There's only 2 possible outcomes. That's true because either you get the question right or you get the question wrong. Those are the only 2 outcomes we're concerned with. So we have a success right, failure wrong. Number 3, the probability of success is the same for each trial. That's true because each question has 4 choices and only 1 is right? So it's the same probability for each question. And then the random variable x is going to count the number of successful trials. How many questions are we going to get right on this quiz? So, yep, it is satisfied. We did it verbally. Yeah, the conditions are satisfied for a binomial experiment. Let's continue. For each question, what's the probability of answering it correctly? So like, in other words, 1 question, what's the probability you get 1 question right? Remember, you have no idea about history and you're just completely guessing. So the probability that you get a question right, there's only 1 right answer out of 4 possible choices, right? So 1 out of 4, or you can write that as 0.25, 25%. For each question, what's the probability of answering it incorrectly? Well, there's 3 incorrect choices. So 3 out of 4, 75%. Okay, when in this section, we're going to give these values, variables, the probability of a success, we're always going to call that P, and the probability of failure, we're always going to call that Q. Notice those 2 always add up to 100% or 1. So if you have P, 0.25, you can find Q by going 1 minus P. 1 minus 0.25 is 0.75. Okay, we take the quiz and we guess. the answer to each of the 5 questions, what's the probability that you answer all 5 correctly? That would be amazing, right? So first, let's jot down our variables before we jump to that formula. So we have in that formula, if you look back, N, X, P, Q. It's all right here, right? So the N is the number of trials. In this problem, we have 5 questions. N is 5. So let me just start jotting this down. N is the total number of trials, in this case 5. P, we already found, right? P is that 0.25. Q is 0.75, right? Those are not going to change no matter what they ask of us in this overall problem. Now the X will change depending on the question, right? So when you're trying to figure out what is X, look at the question. What's the probability that you answer all 5 correctly? All 5, X is 5. Okay, so now I have all of the variables that are in the formula and I can calculate that, right? So I'm using this now. NCX is 5, choose 5. Right? So I'm going to do 5, choose 5. And then it's P 0.25 to the power of X, which is 5, times Q to the power of N minus X, 5 minus 5. Right? So I just followed along precisely with that formula and just plugging in the values of the variables. Now I have something I can calculate, right? So 5 choose 5 turns out is just 1, and 5 minus 5 over here is 0. So this simplifies to 1 times 0.25 to the power of 5 times 0.75 to the power of 0. And if you remember from algebra, anything to the power of 0 is 1. And if you multiply things by 1, you get the same thing back. So we kind of don't even have to write those ones. This one just boils down to 0.25 to the 5th power, which then I've jumped to my calculator. 0.25 raised to the 5th. Right, I'm getting something pretty darn tiny. Right, 0.25 to the 5th is about 0.00098. Okay. And it does say round to 3 decimal places, so if I guess I should do squigglies. That looks like 0.001. All right. So darn, it doesn't look very good for us if we're just guessing on this test or quiz, I suppose. Okay. How about you answer all 5 incorrectly? Okay. That would mean X is 0, none right, all wrong. So that would be N choose X, P to the power of X, Q to the power of N minus X. And that's how that one will break down. 5 choose 0, you will find is just 1. So this is equal to 1. That's equal to 1. Really, we're just calculating the 0.75 to the 5th power. So 0.75 raised to the 5th is about 0.237. Okay, so I'll go approximately 0.237. And we kind of get the idea of this formula. Now we can start filling out the overall probability distribution here. We already did 0 and 5. So the 0 was the 0.237. And the 5 was 0.001. Now we can fill out the rest. This one right here, what's the probability that you get exactly 1 right or exactly 2 right, etc. Each time you're going to use that formula, replace it with the value of X and see what you get. What I'm going to do now is show you StatCrunch. So we're going to complete this table by using StatCrunch, which will be a little faster and another approach that you could use. So let me show you how that works. I'm going to go to StatCrunch. Where is it? Okay, there's my blank StatCrunch page. And if I want to find a binomial distribution where I'm going, and again, these directions you can find in the StatCrunch guide through your notes in modules in Canvas. It's all there, but I go to Stat, Calculators, Binomial. So there it is, Stat, Calculators, Binomial, and you're good to go. Okay, here's the default. N is 10. You just got to change these around. So on our problem, N is 5. P is 0.25. And then I can change this inequality to all of these different options. So right now I'm just going to do equals, and then I'm going to do that first one, equals 1, compute, right? So I get 0.396 for that one. Okay. So that's another option besides using the formula. I guess I could also just check, what if I did x equal 0? Yep, there's that 0.237, so that verifies. And 0.5, and x equal 5, there's that 0.000976, which we rounded to 0.001, check. So it's all looking good. How about exactly 2 answers right? What's the probability of that? That's 0.264. So 0.264. How about exactly 3 answers? Correct, 0.088. All right, we get these a little faster this way, huh? Okay, how about exactly 4 right? 0.015. Okay. And those are all the possible outcomes, right? I mean, you're going to get some grade on this quiz, and either you get 0 right, 1 right, etc., or all the way up to 5 right. And we got this problem done. Okay. Now what I have is my full-on probability distribution completed. Okay. So now if I wanted to figure out like some inequalities, what's the probability that I get 3 or more right? Right? 3 or more right would be all of those added together. Or what's the probability that I get less than 2 right? Less than 2 would be either 0 or 1. I would just add those together. Right? So now you can find ranges in your questions. Once you have that probability distribution all complete, you can get those ranges of numbers, right? And that's what's coming next. So what's the probability of answering at least 3, etc. Okay, so let me show you a couple of ways you can do that. Either you can do what I'm just saying here, add some of them together, or StatCrunch has that feature in it as well. You might have noticed you can put inequalities in. So, oops, let's cancel that. I can change this inequality. What's the probability of getting at least 3 right? That's greater than or equal to 3, and I can calculate that. Okay, so use those inequalities to do those types of problems. Going to be way faster than finding each one individually and then having to add them all up. Right, so definitely use StatCrunch for those. Okay, I think I'll stop here and then continue the notes on the next video. Hope all's well. Send questions my way if you have any. Talk to you.